Let's look at some of these problems. You're told a salt solution has a volume of 250 milliliters and contains 0.70 moles of NaCl. What's the molarity of this solution? So let's start by writing down what we know. Volume is 250 milliliters. And we've used the symbol N before to mean moles. And we're asked for molarity. Remember that molarity means moles over liter. So let's check our units. We've got moles. We have milliliters here. So to make this liter, we move the decimal 3 times to the left. 1, 2, 3. And we get 0.25. So to solve for molarity, we plug into this equation. 0.70 moles divided by 0.25 liters. And you should have 2.8. When we look at significant figures, this number has 2, and this has 2, so we're going to keep it at 2.8. Please make sure that you add the units on the end as well. I know it says molarity equals, but I need to see it after the number as well. 2.8 is our molarity. Let's look at another example. So this one, we're asked how many liters of a 1.3 molar solution can be made by dissolving 4.8 moles of lithium bromide. So we know that our molarity is 1.3 molar, and that we have 4.8 moles. And we're asked to solve for the volume. We know that molarity means moles over liters. We want to solve for the liters for the volume. The correct way to solve for liters is not to divide both sides by mole, because then you get 1 over liter. What I like to do is set our molarity over 1 and just cross multiply. It makes it a lot easier. We get M L equals moles, and then L equal moles divided by molarity. So we can plug into this. So we do 4.8 divided by 1.3, and we get 3.69231. When we talk about significant figures, we have 2 and 2, so we're going to round this number to 3.7 liters. Please make sure you add the units at the end, not just at the beginning. Let's try one more. This question says, how many grams of calcium chloride are needed to make 250 milliliters of 2 molar calcium chloride? This question is a far more realistic use of molarity, because before we were measuring in moles, but there's no scale or no piece of lab equipment that we can go to and measure out moles of something. We're going to measure out grams of it, but we learned several chapters ago how to convert between moles and grams. So let's write down what we know first. We want to find the mass we have 250 milliliters, and our molarity is equal to 2.0. We know that molarity is moles over liter, so we need to go ahead and make this 0.25 liters. Move the decimal 3 times to the left. We know that molarity means moles over liter. And while this doesn't give us mass, we should be able to get between moles and mass using our equality of 1 mole equals molar mass. So 1 mole of CaCl2 equals, and now you have to pull out your periodic table. We get that our molar mass is 110.98 grams of CaCl2. So using this equation and this conversion factor, we're going to be able to get to moles first and then from moles to mass. If we rearrange this to solve for moles, we multiply both sides times liter. So we get moles equals molarity times the liters. So moles equals 2.0 times 0.25 liters and equals 0.5 moles, and we're not worrying about significant figures since we're not having to round anything off here. And this is moles of CaCl2. And now we can do our dimensional analysis. We want moles of CaCl2 to cancel out. We have to put moles on the bottom. And we have to put the molar mass on top in order to go to grams. Moles of CaCl2 cancel out. And we do 0.5 times 110.98. And we get 55.49. Let's talk about significant figures. We have 2 and 2 and 5. So when we round our answer to have two significant figures, we get 55 grams of CaCl2. So if I asked you to make this solution, you would go and you would weigh out 55 grams of calcium chloride.